Hey guys, this is the third video in chapter 4, the video about molarity. Now we've been talking about solutions in class and on these videos, so we need a way to describe solutions and kind of define what's in a solution. And one way to do that, the way that we're going to use in this class is molarity. Well, molarity is defined as the number of moles of solute in volume of the total solution in liters. Now, it's very important that you realize that what I mean by the volume of the solution. The moles of the solute may take up some of the space and add to the volume of the solution. So let's just take two examples real quick. If we want to make a 1 molar solution like we have here, we add in 1 mole of our sample, then dilute it to 1 liter. If I took 1 mole of my sample and then added 1 liter of water, it'd be a little more than 1 liter. So this would be, this number right here would be a little greater. This number right here would be a little greater. And thus I would have a little bit less than 1 molar for my solution. So the important thing here is that this is liters of solution. Okay, liters of solution, not liters of solvent. And sometimes you have that. Sometimes you have you're given liters of solvent and you have to figure out liters of solution. Anyway, let's do a couple examples where we take a look at this and kind of look at the different ways to calculate these. So pretty easy calculation. You know, we have to know that molarity is measured in moles per liter. And we'll use that as a conversion factor in the next slide, but this is just calculating molarity. So we have 14.2 grams of hydrochloric acid, and we have 41 grams of NaCl in this example. So we have our molar mass, 36.45 grams of HCl in 1 mole of HCl, and then we want to divide by 0.872 liters. This will give me the grams cancel out, the mass cancels out, so it'll give me moles over liters. So that'll be my answer there. For this one, we've got 41 grams of NaCl. We have to figure out our molar mass, 58.45 grams of NaCl. Go in 1 mole of NaCl. And then again, we divide by the liters. In this case, we've got milliliters, so we have to convert this first. So we have to move this decimal place over 3, and divide by 1,000. And so we divide by 1.123 liters. And that'll give us my molarity there. So if we look at this first problem, 14.2 divided by 36.45, then get your answer from that division, divided by 0.872, we should get 0.447 molar, or 0.447 moles per liter. And if we look at the second problem, we have 41 grams of NaCl divided by its molar mass, then divided by that number that you get from that division by the volume. We should get 0.625 molar. Again, that's moles over liters. Now, if we have molarity, we can use it as a conversion factor. And let's take a look at that. So in this first question, we've got how many grams of sodium chloride are needed to prepare 350 milliliters of a 0.920 molar sodium chloride solution. So the important thing to know here is that my molarity is a conversion factor. It's the number of moles in 1 liter, right? That's a conversion factor. So I'm going to start with my milliliters, and actually I'm going to convert this to liters real quick, moving that decimal place over 3. So I'm going to start with my volume, 0.315 liters, and then I know that I have 0.920 moles per liter, 1 liter. So you can see how those cancel out, and we can get out of that how many moles we need, or how many moles we have. And so if we do that calculation, and then we can convert that to mass. So let's do that calculation real quick. And we get out of this 0.2898 moles, which then we can very easily convert to mass, right? We've done molar conversions or moles to mass conversions a whole bunch before in class. So 58.45 grams of NaCl in 1 mole of NaCl. Again, moles cancel, and we should get our answer there, moles of NaCl, or in mass of NaCl. So if we do this calculation, we get 16.9, again taking into account significant figures 3 and 3, grams of sodium chloride. So again, using this as a conversion factor. Now we can go the other way, where we're given mass and we want to know how many milliliters contains that number of grams. So again, we start with our mass, kind of, this one's kind of an easy question, but we start with our mass. First step should be to convert to moles, and we're going to have to get to moles in order to use my molarity. And the reason I used 98 is that the molar mass of sulfuric acid is 98 grams H2SO4 per 1 mole. If we use my molarity at that point, we get 3.10 moles H2SO4 per liter. And now we're in volume, right? And we also know that there's 1,000 milliliters in 1 liter, and I'll put our answer over here. So liters cancels, moles of H2SO4 cancel, mass of H2SO4 cancels, and we're left with milliliters with our volume in milliliters. So that's important that we make sure we want to match our units there. So let's do this calculation real quick. Actually, before we do the calculation, what I want to do is kind of point something out. Now, if I'm on a test, if I'm doing this on a test, I'm not going to bust out my calculator before I look at my answers. Because I know this is about 1. This is 1, right? 98 divided by 98. I know 1 divided by 3 is about a third, so I know that I need about 300-ish milliliters, right? So then, this would be, a third of a liter, and then, multiply by 1,000. So if I looked at my answers and I only have one of the answers that match that, then I know that's my answer. Well, I can plug it in my calculator, and you should get 323 milliliters of this solution contain a mole. So that's what we need to do there. Alright, so that's using it as a conversion factor. One last thing we have to talk about is actually what happens whenever we look at a solution by itself. Now here again we can see moles divided by liters. So I have a 1 molar solution, 0.5 divided by 0.5 gives me 1. But what happens if I change the number of the amount of solvent? So what I'm going to do is I'm going to dump in twice as much solvent. So you can see the line of my beaker going up. And of course, then if I do 0.5 divided by 1, I get 0.5. Now, I didn't change the amount of moles of my solute, right? This stayed the same. What I did was I doubled the solvent. And that is an important thing called dilution. Okay? So dilution happens whenever we take some of our original substance and we dilute it by adding our solvent, by adding more of our solvent. And it's related through this equation, M1V1 equals M2V2. So let's look at a very, very quick example of that. Now, the one very important thing that I want to point out is that this is the same solution, right? These two things, these two solutions are the same. Never break out M1V1 equals M2V2 for solutions that are different, even though you might want to. And we'll look at that in the next video. So for dilution, we have this type example where we have two volumes or two molarities and a volume, and we're just asked for the other variable. So again, our formula. And now we just have to kind of pick out which one. So what is the molarity of a solution prepared by diluting? So this is where we start, V1, and this is where we end, or this is where we start as far as molarity goes, M1, and this is where we end, V2, and we want to know M2. So before I approach the problem, before I do the problem, I want to make sure I understand what's going on. I'm adding a ton of solvent, right? It starts out at 282 milliliters, and then I almost multiply by 10. It's 5 times as much, right? So since it's 5 times as much, I know my molarity should decrease by about that. So make sure your answer makes sense logically as well as mathematically. So there's my V1, my M1, and my M2 is what I want to figure out, and my V2 is 1.19 liters. Alright, so let's do this calculation and figure out what my M2 equals. So we do this calculation and we get 0.389 molar. And that matches our prediction because we added a bunch more of our solvent. Our concentration, it should be diluted, so our concentration should go down. And in fact, we see that difference there. Anyway, I'll see you next time where we'll use molarity in stoichiometry.